All right, friends, it's your boy, Mr. Shagney, coming at you with Unit 3, Lesson 7, Scale Drawings and Maps. So today says, let's explore scale drawings. So recently we've been talking about scaled copies. Now we're going to be looking at scaled drawings. So it says, here are some drawings of a school bus, a quarter, and the subway lines around Boston, Massachusetts. The first three drawings are scale drawings of these objects. So these are scale drawings. And so if you look, we're looking at them to try to identify what this is, and the next three drawings are not scaled drawings of these objects. And so you can kind of see that's like mashed up, and you just have some things not to scale. So it says discuss with your partner what a scale drawing is. So today we're going to talk that a scale drawing is like a scaled copy of a real object, but it is a drawing that shows one flat surface of the objects. But it is a drawing that shows one flat surface of an object. Okay, so this is the definition we're going to use today. Up here, I'm going to give us a few more things. So when we come to that conclusion up here, next to this, I'm going to write, it's a scaled two-dimensional representation of actual objects or places. So it's a scaled two-dimensional representation of actual objects or places. And in this activity, we're really developing what a scale drawing is, and so we're coming up with a working definition that we can use to apply it. You are going to take what we've learned about scaled copies and start applying that to scale drawings in today's activity. So I'm going to move on to the next activity. The next activity is called Sizing Up a Basketball Court. And so it says your teacher will give you a scale drawing of a basketball court. The drawing does not have any measurements labeled, but it says that 1 centimeter represents 2 meters. So this is the drawing that it's referring to, right? So this, you'll receive this in class today. And it says, number 1 says, measure the distances on the scale drawing that are labeled A to D to the nearest tenth of a centimeter. So we're gonna be measuring in centimeters today. So I'm gonna measure these distances to the nearest tenth of a, so this one is A is 14 centimeters. B, and I can probably zoom in because maybe some of you don't trust me, right? B, if I'm measuring B, I'm gonna go down here as close as I can. B looks to be about 7.5 centimeters. It says to the nearest tenth. Here, it's from hoop to hoop, so that little circle to this little circle over here. That looks to be about 12 4/10 centimeters, right? So from that hoop to that hoop there, it's about 12 4/10. And then we're measuring D here. Measuring D from there, this is from the 3-point line to the court, that's about 5/10 centimeters. So we measured each thing on here. I'm gonna zoom out again. So I've measured what it told me, so that was number 1. It says, record these results in the first row of your table. So I'm gonna take these results that I got here and I'm gonna put them in the table. So the length of the court we found was 14 centimeters. And that was in our scale drawing. The width of the court is 7.5 centimeters. The hoop to hoop is 12 4/10 centimeters. And the 3-point line is half of a centimeter. So that's what we found. So we've done one, We follow those directions. The statement, so it says the statement 1 centimeters represents 2 is the scale of the drawing. It can also be expressed as 1 to 2 meters, 1 centimeters to 2 meters, or 1 centimeters for every 2 meters. What do you think the scale tells us? The scale tells us how to use the measurements on the drawing to find the actual measurements. So the scale tells us how to use the measurements on the drawing to find the actual measurements. So that means that for every 1 centimeter I have here in this drawing, it's going to represent 10 in the actual court itself. Like 10, we're going to have it represents 10 meter, or not 10, my bad. So 1 centimeter of this represents 2 meters on the actual court, and I have 14. So the next question is going to show us what we need to do there. So it says, how long would each measurement from the first question be on the actual basketball court? Explain or show your reasoning. Well, since I know that it's 1 centimeter for 2, I'm thinking about what's the relationship between these two things here. So I'm thinking, what happens to 1 to make it 2? Since we're still talking about scaled copies, that's our scale factor, which is times 2. So I'm going to multiply each one of these numbers times 2 to get the actual court. So 14 times 2 is 28, so this is 28 meters. 7.5 times 2 is 15 meters. 12 4/10 is 24 8/10 meters. And 1/2 times 2 is 1 meter. And so on the actual court, we're going to take each one of those numbers and multiply by 2 because our scale tells us what our scale factor is, like what we need to multiply each number by to get the actual court drawing. It says on the actual basketball court, the bench area is typically 9 meters long. So if we know that to multiply, we would get this, multiply by 2, we need to think about what's the reciprocal of 2 on this problem. Without measurement, determine how long the bench area should be on the scale drawing. Well, I'm going to take 9, and the reciprocal of my scale factor is 1/2, so I'm going to multiply 9 by 1/2. This gives me 9 over 2, which means I take 9 and I divide that by 2, which equals 4.5 centimeters. And the last problem says we're going to check that. So we're going to check to see if that gives me 4.5. So these are what they're referring to. So remember to measure appropriately. So I get my ruler out. That looks to be 4.5 centimeters on the actual scale drawing. So that works out. So that is our activity there. And then we're going to be looking at our next activity. So I'm going to zoom out for us for a second. Our last activity of the day is going to give us a different, going to have us use our index card. So we used a ruler there, so now we're going to use our index card. We will be using a ruler for part of this today. It says here's a scale drawing of some of the world's tallest structures. About how tall. This tells us that we're allowed to estimate that it's not going to be exact, and so about how tall is the Willis Tower, about how tall is the Great Pyramid, be prepared to explain your reasoning. So what I'm going to use is I'm going to use my index card, and I'm going to measure, right? I'm going to measure the line segment that they gave me. So I want us to realize that this is not, this right here is actual distance is represented by that line segment. So this tells us the actual distance if we measure this line segment and then apply that knowledge. So this is about 100. So I'm going to take this and I'm going to measure the Willis Tower. I'm going to mark on the Willis Tower every, so that's 100, 200, 300, 400, and maybe like halfway. So the Willis Tower, so I'd say WT is about 450 meters. And what I did is it's about 4.5 line segments tall. Now I'm gonna apply the same scale to the Great Pyramid. So Great Pyramid, I have, right? So make sure people can see, so in case anyone's wondering what I'm doing here. This, if I drag that over, is about right there. So this is about 125, so maybe 125 meters, and that is 1 and 25/100 line segments tall. And if you take this number and you multiply it by 100, it gives you this number over here. So it's like your scale factor in some sense there being applied through measurement. This one says about how much taller is the Burj Khalifa than the Eiffel Tower. So if this is my Burj Khalifa, right, how many line segments is this? It's 1, 2, 3, 4, 5, 6, let's say about 7. So BK is about 700 meters. That is 7 line segments tall. Right, so, and then I need to measure the Eiffel Tower here. So that's 1, 2, 2 and like a 2.5. So the Eiffel Tower will be 250 meters. That is 2.5 line segments tall. And then we want to find the difference between these, so we want to do subtraction there. So this one, 6, 10, 5, 4, 450 meters. So the Burj Khalifa is about 450 meters tall. Now that this is an approximation and that in my picture I could have stretched it a little bit to make the scale a little off. So what we're going to do now says measure the line segment that shows a scale to the nearest tenth of a centimeter. So we're measuring this to the nearest tenth of a centimeter. So I'm going to zoom in here because I'm sure that people will not think that I'm doing this right. So this is about, that looks like about 9/10. So 9/10 of a centimeter equals 100 meters. So if you're given, so this question down here, what I just did is if you're given an actual line segment, you could measure it with centimeters or inches to see the scale if you wanted to create one. So 9/10 of a centimeter is about 100 meters. So if I were to measure that, it would tell me, closer, it would give me a better estimate of how tall each one is if I'm actually using a ruler versus the index card. And so this is our last activity for today. And so the goal is that we really want you to understand that in a scale drawing, right, you're still using scale factor. The only difference now is that we're going to tell you that there's a relationship between two things, and you got to find out how much larger a number is than another, and that's going to tell us our scale factor. You're also going to be measuring. So I look forward to seeing y'all shortly.